Yeah, good morning. So, my name is Josh. I look like this on the internet. Fun fact about myself is that I like cats. I'm also allergic to cats, which I feel like is a criminal injustice. So I have a request from everyone. This is my Twitter. If you would like to send me cat photos, I would be forever grateful. I also should apologize. I was in a scooter accident recently. And because of that, I have to be a little bit mindful to speak carefully because I fractured a tooth. So I'm going to try not to bring us too far into the lunch, but I might run a couple minutes over. Performance. When we talk about performance, I think often these are the things we're talking about. So it's about making sure that we render on the server or at compile time so that we send a fully formed HTML document to the client so that we get that first paint really quickly. And then we also want to make sure that it's interactive pretty quickly thereafter. So we code split, we tree shake, we do all this stuff to make it so that we're sending less stuff up front and trying to delegate, optimizing our assets, right? There's all these things that are focused around the first couple of seconds that the person is using our thing. And we don't really talk so much about like everything that happens afterwards, which for most experiences, you spend a lot more time using a thing than you do waiting for it to load. So this talk is called Saving the Web, 16 milliseconds at a time. It's somewhat of an exaggeration or like maybe an overdramatic title, but I do think this is kind of more important than people think. I think it's also valuable to look like contextually and at the historical context to figure out why we think about performance in the way we do. And I could find articles dating back to 2012 or so, like this one. How 1 second could cost Amazon $1.6 billion in sales. It even had this cute little infographic about how like the longer you wait, the more likely you are to abandon. So there's like this guy who's grumpy and he's like out of there. There's like articles about this, like they keep popping up. Here's one from this year. Amazon found every 100 milliseconds of latency cost them 1% in sales. I'm not sure why this article shows this photo of a guy clearly mansplaining something to an unimpressed coworker. Bit of an odd choice, but they can do that if they want. I think it's a valid point though, because if I'm looking for an air conditioner, I Google air conditioner and I'm presented with this like never-ending list of options, places to buy an air conditioner. So I click on that first result, 2 seconds pass, I'm still staring at a white screen. It is so easy for me to hit the back button, because it's going to be cash, it will go right away, and just try Walmart or Best Buy or any of the other options. So in the context of an SEO-driven e-commerce platform, initial page load is critically important, because it's so easy to jump to a competitor. I think that the key to this is to realize that people are not patient, just like generally. I'm not. I'm totally like this grumpy guy, that's totally me. Like, I don't have the patience. But the thing is, we don't get more patient after the page loads, right? Like, we don't become suddenly more gracious. I have some numbers about this. So the general benchmarks, things we should shoot for, is that if I click on something or enter something or interact with the page in some way, I want to see an update. I want that change to be reflected in the UI, ideally in less than 100 milliseconds. And when it comes to animation, we're even more critical, and we notice latency even more. Ideally, we want our animations to run at 60 frames a second. That's generally seen as the amount of time where no longer can your brain parse it as a series of repaints, but it seems like a fluid motion. That's and you can get away with less than that, but that's the golden standard. And when you do the math, that means you only have 16 2/3 of a millisecond to do each frame. That's where the title came from. Yeah, let's talk about interactions. So I saw this really cool thing by Monica Dinculescu, which I'll open because it's cool. It's just a box you can type in, but the idea is that you can tweak the amount of input delay. So if I set it to 100, and then I try typing hello there, it's okay, you can definitely tell that it's a bit not super responsive, but it's not critical, at least not to me. I think different people have different thresholds. But if I set it to 200, and it's then when I try typing, it's just it's really not good, because there's this compounding effect, right? It's 200 milliseconds for every input, and if I can type faster than that, then it builds up. So really cool tool, highly recommend checking it out. And kind of related to that, I have a case study. So I saw this post on the Orange website a while ago about this EMT software. And so the author is this guy named Hillel Wayne, and he was recently certified as an EMT. So he's the emergency medical technician that goes in the ambulance to get people that are having emergencies. And it turns out that when you're in that ambulance with that patient going to the hospital, you have to fill in this form. It's called a PCR, a patient care report. and it collects all the information that the hospital will need so that when you get to the hospital, there's that handoff, right? The emergency technician doesn't stay with the patient, they have to go on some other call, and the doctor takes over. And so this form is like meant to give the doctor all the context they need about what's happening, you know, if the person took any drugs or what they last ate, what the current symptoms are, all that stuff. There's 30 million of them filled out per year. I think that's just in the US. And they're written in these like high stress, high tense situations of like, you're in the ambulance and it's bumpy, and you're trying to fill out this form with a pen and paper. And like, obviously, this is a recipe for disaster, right? Like the blog post gives this example that if the person means 100, but it looks like 160 in terms of like the number of milligrams of some thing that was supplied, that could be like critically bad. So the people who, I guess, administer this system saw this problem, and there were enough incidents around this that they built software for it, right? Software is the kind of thing that can solve these kinds of problems. And so they built it, it takes less time to fill out, they trained the staff, they fixed the bugs, they did everything right, they deployed it, and everyone still uses the paper one. And the reason that they do is that the machine in the ambulance that it runs on comes with a 250 millisecond input delay. So like, if we go back to our friend over here, and we set it to 250, and then we try, whoops, I can't even type. We try typing something. Like, you can see why people would not use this, right? And that's really bad, because people should use it in this kind of situation. So I think it just goes to show that like, we really need to be mindful of this as like, and most of us don't work in these like life or death situations, but it's just like, if people are not willing in those situations to put up with that kind of input latency, they're sure as hell not gonna be willing to put up with it on like, you know, some blog or something. Okay, so how do we fix this? There's actually quite a lot of resources around this, and I don't want to dive too deep into it in this talk, but I think the biggest cause for these kinds of issues often come down to rendering, whether it's you're rendering adjacent components that don't actually need to change. I think that's probably the most common thing. And so the solution for that just is trying to avoid rendering when it's not necessary. And so the tools for that, in like our class world that we all lived in until recently, or maybe still do, should component update was the way to do that. You can check to see if the props have actually changed, and if not, you can skip it. There's also things like React.memo, which essentially just check all the props and avoid rendering if those props haven't changed. And so if you have a form and someone types in a field, all the other fields shouldn't have to re-render. There's also, I linked some resources as well, just for the documentation for this, as well as a pretty cool guide about how to use this. It's really important with this to profile, though, because it's very easy to like have the pendulum swing too far and then to over-optimize and to spend all your time looking for any wasted render. And the truth is that like sometimes it's okay. It's the kind of thing where you really need to check, and we'll do some checking in that manner shortly. So what about animations, right? I don't have a like anecdote about how people can die if the animations aren't optimized, but I still think it's really important, and I have a bit of a winding road to get us to why. So animations, I'm like personally an animations advocate, but I think one of the things they do really well that maybe hopefully all of us can agree on is that they make the animation feel a lot more tangible. Because in the real world, right, when things move, they don't suddenly blink from one state to another. Giving your app like tasteful, minimal animations can really help it feel like a real thing. And the thing is that web apps and websites don't exist in a vacuum anymore. We live in a world where people will typically use a native mobile app and a web app like side by side in the same day. And so it inevitably draws contrast. Speaking of contrast, and speaking about the way we typically think about performance, I'm actually curious if anyone wants to guess, like yell out, how big is the Facebook mobile app today? 250 is a remarkably good guess, because it is 255. So kudos. Yeah, and it's funny because I've given this little question in a talk earlier this year. It used to be something like 500 and something. So they've gotten a lot better, but it's still 250 megabytes, right? And when you think about Mario 64 was 32 megabytes. That was a big game. And if we think about like how much friction is involved with actually downloading and using an app, first you have to find it in the App Store. There's no like UI, you have to actually search and find it. Then it's going to prompt you for your password, and who the hell can remember that? It's going to have to download all of these megabytes, which you may be on like a metered connection, you may be on like an elevator, this might take a long time and eat up a valuable commodity. Wait for it to install, figure out which home screen it installed to, because that always takes me a while. Tap on it, wait for it to open. And it's like you compare that with Facebook.com, wait 3 seconds, you're good. So why does anyone do this, right? Like, why do mobile apps even exist? Why would anyone go through all this when this nice, fast web alternative exists? I think there's a lot of reasons. But a big one, I think, is that mobile apps tend to be nicer to use. And like, user experience is the broad term that I would say that mobile apps tend to do better, which is like this big amorphous thing. But one way to look at that, I think, is, oh, I don't have the slide I thought I did. I can just talk about it. It's just around like how things feel and move and how they're animated. So this gets back to like animation performance and why I think it matters. I was also listening to a podcast with the React podcast, number 35. The guest that week was Matt Perry, who's the author of Pop Motion and Pose. Nowadays he works on Framer. And he had this really good point that it's about relevance. And so the way that I like to think about this is, who remembers AOL? Like okay, a few of us, right? You had keywords, you've got mail. There was this whole era that existed that was on the internet, but not the web. And that doesn't really exist anymore, or at least I don't think it does. I think this might actually still exist. I think I saw that in at least 2015, there were still 2 million people paying for the original dial-up AOL experience. So it still exists, but it's not relevant, right? People don't use it anymore. And the reason people moved to the web is that it was a better experience. So what happens when native mobile apps continue to offer a better experience? Is the web going to be this kind of thing that everyone else has moved away from and our grandparents still use to check the sports and the weather? And for all of the web's faults, and it does have a lot of faults, I think that it's truly remarkable. One way that I think it's remarkable is that I can go to an electronics store and buy a Chromebook for a couple $100. This is a screenshot of Code Sandbox, and Code Sandbox is amazing, right? It's an online IDE. And I saw they recently allowed you to deploy through Code Sandbox to Netlify and Zeet. And so the remarkable thing about this to me is that with no dev time environment, I can start building an app on the web for the web, and I can click really, really easily to have it deployed globally and immediately available for free, which is remarkable. No other ecosystem lets people do that. And I think because of that, you have this really rich ecosystem where it's really low friction for developers to get started, really low friction for consumers to try using things, and people just build cool stuff because of that. I think if we want to make sure that this remains the case, right, if we want people to continue to use the web and benefit from it, then we have to make sure that we're competing with native apps on this quality level. This is where that slide I thought was before. Okay, let's look at an animation. Let's talk about accordions. So I'm going to pick on Bootstrap. And not because this one is a particularly heinous example, just that it's one of the more common ones. So speaking of profiling too, an accordion, for those who aren't familiar, it's this kind of clustered, you have multiple items in a group and only one can be open at a time. So they open and close like an accordion. I'm going to hit record, actually, before I do that, because this is a pretty expensive computer. So I'm going to throttle it down by 6x, and then I'm going to hit record. And I'm going to toggle it open and closed. I'll do that one. Okay, let's see what we get. It's also important to say that 6x is it sounds like a lot. It's still way faster than an Android device from 4 years ago. Okay, so the way to read this, I'll make it a bit bigger. And yeah, you can zoom there too. So this area up here, the green kind of mountains, is your frames per second, where 60 frames per second would be full. And so you can tell just from this that it's a bit rocky, it changes, it's not quite maxed out at the top. And let's just dive into, let's say, this area. Yeah. Okay. So we're averaging about 20 milliseconds, 25 milliseconds per frame. This is actually better than it usually does. Usually I see it around 30 frames a second. Yeah, this actually did remarkably well, but not always the case. And so if we dive into one of these frames, this one looks good. We have this brief moment of recalculating style. Then we have these 2 purple bars. I don't know what this JavaScript here is doing, so let's pretend that isn't there. But we have these 2 purple bars that are calculating layout, and then these 2 green bars that are doing painting. And then we should have, yeah, a composite at the end. So what are these things? What are they doing? Let's go back to my presentation. So to talk about these steps, we have to talk about the pixel pipeline, which has a really cool name. I gave it a matrixy graphic. It's not actually that exciting. I'm sorry. Essentially what it is it's the series of steps that can be involved when it comes to updating what's on the screen. So whenever something changes on screen, it's gone through this pipeline, and some or all of these steps are involved. So first, you might have some JavaScript that kind of triggers the change. Style, I think, is the process of figuring out for every DOM node, which CSS rules apply to it. So reconciling this DOM node has this selector, and so you look up which styles apply. This one is almost always really quick, so I don't really worry about it. Layout. Layout is the process of figuring out when things move or change. So if, in the accordion example, the thing's height has changed. And so not only does that div that changed have to have its layout recalculated, so does everything below it, because all those things have to move up. That's part of layout. Paint, I believe, is the two-step process of figuring out which color every pixel ought to be and actually filling it in. One subtle point with that is that it happens on a per layer basis. So at the end, you might wind up with several layers that have each been painted. Compositing is the process of taking multiple layers and stacking them into the final product, what you see. Style and composite tend to be pretty quick. Layout and paint tend to be pretty slow. And the interesting thing is that different CSS properties will trigger different steps in this process. So for example, there's no value I can set for background color that will trigger layout. It can't happen, right? I can't choose a size as a background color. It's only a color. So it'll always trigger paint, but it'll never trigger layout. There's a cool website called CSS Triggers, which kind of goes through and shows which CSS properties affect which steps in the pipeline. It's not always so clear-cut, and so it's not like I wouldn't take everything you see in here for gospel, but it's still a good sense of understanding what properties can trigger which steps. The golden rule, the thing that you hear, is that there's two properties and two properties alone that can skip both layout and paint and thus produce really quick animations because they only need to deal with style and composite. And those properties are opacity, which is how visible something is, and transform. And transform is kind of like a bucket of props. It lets you move things around, rotate things, scale them. Yeah. So how do we use this information to build a better accordion? Well, it's kind of a trick question because it's actually really hard. It's not really feasible. And the reason for that, if we jump back to this accordion, is that all of the stuff below this on the screen has to change. And in fact, if I mouse over this paint, you'll see that it's actually repainting almost the entire document on every frame because everything has to move up. And so you could transform all that stuff and translate it up, but when you do that, it messes with the natural layout calculations, and it makes it really hard to solve all the other problems of laying things out, because anything below the thing that you're transforming will not move with it. It's this big kind of once you start unraveling that thread, soon you're just left with a pile of yarn. It doesn't help you. But we can do something close, and we can do something that'll perform really, really well and still produce the same visual effect. So here's my accordion. The way that it works is that you'll notice when I click on it, immediately it fills the available space. So the stuff below here, these two other ones, they drop down. By the way, these are Scottish fold cats. They have funny ears. What I said earlier about Twitty Me cats, if you have one of these cats, please, please, please. Okay, so I do a couple other things though. It's not just a matter of everything happening in one frame, because the actual content has an animation applied, the stuff inside this box. And so it does two things. One is that it fades in. The other is that it slides down by, I think, 12 pixels. So it still gives you that vertical motion of something unpacking. But it does so in a way that doesn't involve applying a transformation on everything else in the document beyond just that first frame. So code. I'm gonna move pretty quickly through this. And the reason for that is that this isn't really a talk about code. I'm hoping this is more of a high-level inspirational ideas talk. Also, I'm going to be sharing all of this code at the end. So if you are curious about this particular accordion implementation, all those details will be available. So with that in mind, here we go. I have an accordion item component. The button that you see here is the actual visible part of the every closed item, everything in there is the button. Oops. And so the button has the title, which is the name of the header essentially. I also have this icon, and this is where the first little animation happens, which I should probably highlight. This is a cute little flourish, but the little carrot here swivels from pointing to the right to pointing down. I'm a big fan of little details. So for this, we see our first animation, and it's a CSS transition. So what I'm saying is that the transform property, any changes to that should be interpolated over a 400 millisecond window. And the change that I have here is that I'm swiveling it by 90 degrees. So when it's open, we want it to point 90 degrees. It always goes clockwise, which I have to mirror now. So it goes from pointing to the right to pointing down because it's clockwise. And when it's not open, when it's closed, it should be at 0 degrees, which just points off to the side. Then the other part is we have, and this is I think the common way of doing this in React, you essentially just choose to render some stuff based on a Boolean prop. So if this accordion item is open, then render all this stuff. You'll see I have a class name applied, and that class name has a keyframe animation. So we can hop into the CSS and see that. I have kind of two keyframes here. One is that subtle vertical motion I talked about. The other is just a fade in from 0 to 1 on the opacity property. And then I combine them here. I say, apply the drop-in animation over 375 milliseconds, which a bit with a nice little custom ease, and then do the fade in over a second. One other thing before I move on to is this way of rendering things has a significant cost to it, which is that when isOpen is false, this whole DOM chunk gets thrown away, which means that React has to find it in the DOM and remove it. And then when you toggle it open, it has to like re-inject it. I did a bunch of testing on a bunch of devices and found that this was surprisingly not that big of a deal. Like usually it's not that much of a cost, but definitely like experiment with the alternative of doing this, which is just to toggle the visibility. So rather than removing it and reinserting it, just like play with opacity and display none block. But in this case, it was okay. So the next thing I want to talk about is will change. So who's familiar with the will change property? Cool, that looks like maybe a third or so, maybe like a fourth. It's a way to let the browser know that it should optimize this thing. And thinking back to our pixel pipeline from a few minutes ago, you can only skip the paint step if the change being applied is in its own layer. And I think these layers are distinct from like z-index layers. The idea is that like the browser will group things, and then once they're grouped as a layer, the browser can essentially just treat it as a texture. So this is why, if you've ever seen using transform scale, like skews text and does weird things, it's just that it's like treating that whole element as a layer on the video card and it's transforming it as like a single thing. Will change is a way to suggest that the browser should do that. It's not the only time that happens, I think. I think browsers will infer this as well. This is just a way to lock in that that definitely happens. You want to be careful with it though, because if you abuse this too much, like this is a trade-off. It's going to cost video memory, and typically the devices that most benefit from it are also devices that have really limited video memory. So definitely like don't reach for this too often, but if there's a really critical animation that you want to make sure runs well, it's a really good tool to know about. The other thing is that like we have these rules, right? Like only use transform and opacity. This might be the rebel in me, but I don't like always following the rules. I think that as long as you're making sure that it runs well for the devices you're targeting, don't let anyone shame you into like, if you want to animate height, then try it. I used to work at Khan Academy. And at Khan Academy, we had a menu, and we wanted this kind of animation. And you'll see that it does the like accordion thing. Like all the stuff below moves down and up, which means that you're paying the cost of layout and paint on every frame. But we had two things working for us that made this not like a cardinal sin. The first is that we knew this menu was only going to work on desktops because the user base that we had for this, which was teachers, almost exclusively uses laptops and desktops, and I think we even had a different menu for mobile. So we didn't have to worry about the old Android phone use case. The other is that we knew we had a very small amount of things, right? So perhaps unsurprisingly, there's a correlation between how long it takes to do those calculations and how much stuff there is to do it for. So in the accordion example, you might be like expanding this huge world of stuff, and like in the Bootstrap example, the stuff affected is all the stuff below here. This is a navigation menu. We're not going to have that much stuff below it that has to be recalculated. So we did it, we tried it, it worked well enough, and we shipped it. Okay, let's look at another animation. So I made this like fake Twitter. I did this for a workshop, and what I wanted to focus on is this like button. So I'll zoom in on it. I had a lot of fun with this, by the way. These animations are so much fun. Outside the scope of this talk, I really wanted to dive into it, but alas. But there's a few things to note here. One is that the heart itself kind of grows and swells. There's this pink popping bubble behind it, and then there's 12 particles that kind of go off in random directions. When I look at the profile of this, it's like, okay, it does, so you'll see I'm throttling, I'm doing a 6x slowdown, and it's still technically fitting where every frame happens within 16.6 milliseconds, but it's like really tight, like it's not, there's no breathing room. And the reason that's a problem is that I used a library called React Spring for this. So the CSS animation we looked at before happens kind of in its own thread because it's CSS. This one, I wanted to have the spring physics. And spring physics gives this really fluid organic motion. It looks, in my opinion, a lot nicer because I'm using that library. But it does mean that it runs on the main thread. And so there's this cool thing that Vincent Reamer built. I think he spoke last year, so some of you may remember him. But the idea is that we often think about CSS animations, or just animations in general, like within a vacuum, within these contrived demos. The truth is that this like button that I have, when I click on this, I need to make a server request because I've liked something and that has, we have to persist that on the server. And that means we're going to have to be running some other stuff on the main thread. And so this cool demo lets you stall the JS thread. And so you'll see CSS animations, it's still going to wobble until the end of time, it's fine. GSAP and PopMotion, which are JS animation libraries, they don't do so well because they're fighting for the same resources. So how do we solve this? What do we do? Well, we have a few options. One option could be to use less particles. Unsurprisingly, I am not a fan of this option. I want as many particles as possible. It also doesn't really, because even if you had two particles, those two particles are still going to be frozen if you do other stuff on the main thread. You could use CSS transitions, which would help, but then you lose the ability to have those nice fluid spring physics. And even then, we're still pretty close to our budget, right? So older Android devices probably not going to run as smoothly. Third option is the interesting one, the one that we don't see talked about a lot, which is sprites. So like in video games, right? You can take an animation and record it into a series of frames. I know this is really small. I don't think I can do much about that. But essentially, it's one image for every frame stitched together in a film strip. And so then, like a flip book, you just play the images one at a time, and you get this like pretty good looking thing. Here it's like I had to shrink it a little bit more, so if you do happen to tell that it's a bit aliased, it's just like, it's the demo, it's not actually a feature of the sprites itself. Yeah, because normally it looks like that. So how do we do this? Let's look at the code, because I think this is really cool. So you'll see that my component is just I have a wrapper with an image. We'll look at that in a second. The wrapper here I'm constraining to be the size of the first frame. So let's say that our image is 72 pixels tall by, let's say, 1,500 pixels wide, because it's this long strip. The container is set to show just a single cell of that, and then it's truncating the overflow. It's hiding the overflow. Then I have, on the image, I set it to be height 100% so that the image is the same height as the container. And then I have this animation. And so now let's look at the keyframe. Essentially what this is if we have our square container with like a long, long image, which goes here, I want to like move it through from one end to the other. And if I was to do this kind of smoothly, then it would just be like you're just watching a bunch of hearts fly by, right? Which isn't really what we want. But there's a really cool thing, which is this steps line here. So this is like an easing function, like linear or ease in. But rather than applying some sort of fancy curve, it breaks it like a staircase into a number of discrete jumps. And the number that you pass is the number of those jumps. So if my image has 34 frames, I want to jump 1/34th of the available, like from 0 to 100, 1/34th every time, which corresponds to each frame. So essentially, you're just shifting this image in these hard jumps so that every frame is kind of shown in the middle. And when you do that, you get this remarkable performance. Like it takes very, very little resources. It's essentially like playing an animated GIF, which, by the way, you could also do. The benefit with doing this over an animated GIF is that you wind up having a lot more control, so you can pause the animation, you can change the speed, you can do a bunch of like different cool things. But really just recording a GIF and playing, it's also a good option. Fun fact, by the way, so I talked about this at my React Europe talk, and then someone, I forget his name, he was one of the lead devs at Twitter, came up to me and told me that this is actually how they do it, for the same reason, that it performs much better. So you play with this technology whenever you like tweets. So how do we do this? Well, because like there's like we looked over the code, but then how do you get this long film strip of an image? I just use any sort of screen capturing software like Giphy Capture. Just record a GIF, like create a box, like set the part of the screen you're recording to be the thing. Click record, click on it to trigger the animation. Then there's this cool thing called Easy GIF, which essentially just takes an animated GIF and splits it into that film strip style. And then if you really want to, you can use something like Photoshop to trim out the background. So like just select all the white and delete it in case you want to put this over something that like you want the background to be transparent. It's a bit tedious, but it takes like 10 minutes maybe. And the implications of it really open a lot of possibilities, because now we could have as many particles as I can confidently display on my machine, which is a pretty cool thing. Okay, I have one more thing to talk about. I'm going to go a little, yeah, I can talk about it. Let's do it. So I built a thing. The thing that I built is called TinkerSynth, and it's essentially a generative art technology. So the idea is that the canvas on the left over here shows the current result, and then these controls change the things on that canvas. So like, and actually I'm going to turn this off and then just click this button because this like shuffles all the parameters. This was a really fun project. I had a lot of fun with it. But I had a technology problem with it, or a performance problem. I think I go into that in the slides. The problem is that this is what the performance was initially like. Keep your eye on the slider on the right and see how like not good it is. Like it's stuttering behind my cursor, and even the little visualization. Like it's just kind of a big mess. And this was like frustrating, right? Because I had gotten pretty far in this project only to realize that it was not fun to use. So a couple things helped me out here. One of them was kind of this long-forgotten hero of the web worker. Because the way this works is that this thing over here is a canvas. And a large part of the work is just figuring out how I'm going to turn this off and back on again. Figuring out like where all the points need to be. Because I'm doing this, there we go. The way this works is that every row is a series of 500 straight lines. And so if you just do the math, that's like a lot of points. But then also there's this occlusion, right? There's the fact that previous rows, like the third row might have a swoop that goes behind the second row. And the way I do that is that I look for intersections for every point for every row. So the first row, I go point by point and see if that, or I guess the second row, and check if that point is behind the first row. So it's like this incredible amount of computation that's required. And that was happening on the main thread, along with like my cute little animation over here on the side. But you can move that calculation to the web worker, and then suddenly, like as long as you're on a multi-core machine, they're not fighting for the same resources anymore. The other thing that, this is also a really useful blog post about web workers, highly recommend. A bit ominous and gloomy, but still a very good read. The trusty sidekick to my long-forgotten hero is off-screen canvas. And this is a brand new API. I think it's only in Chrome. But what it lets you do is, and actually I should back up a little bit, the problem with web workers is that they are, I guess the big limiting thing is they don't have DOM access. So they're a separate JS environment, and you have to pass messages across this chasm, and you can't update the DOM. But off-screen canvas lets you transfer control of a canvas to a worker. So now, not only can I calculate where all the points need to be, but I can actually draw them in that other worker, which means on a different CPU core. And like the difference in this is night and day. Like, I mean, you saw like this whole stuttery mess just becomes like this nice little, like everything just kind of works. Yeah, it's remarkable. And I think it has to do with the compounding, like we looked at with input latency. It's dramatically faster. It's not twice as fast, which you think it might be because it's 2 threads instead of 1, but it's like dramatically different. What else did I have? Yeah, browser support sucks, but hopefully that'll change soon. The good news is that the web worker, that works everywhere. So, and that was about like maybe 65, 70% of the benefit. So definitely web workers are great for this kind of thing. I don't have time for the code, but again, code is made available. In conclusion, so I think that the initial like view that we have about performance is not false, right? Like people really don't like waiting for pages to load. It's just that people also really don't like interactions and input latency, right? And they also hate animations that don't run smoothly. Like all of this stuff is bad. I think context really matters. So if you're building an Amazon competitor, then what they're doing and what these news posts are all about makes a lot of sense, that your job is to get your item in front of the person's eyes as soon as you can so that they don't bounce and go check out search result number 2 or 3. But if you're building something else, right, like if you have a blog and that blog talks about something really valuable, there's not like 6 other blog posts that go over the same thing that are a search result away probably. So I think the best thing you can do is just to like try using the thing that you're building and look for what points are the worst. Like it might be that your thing takes 6 seconds to load and then it runs perfectly, but it's also maybe likely that it loads pretty quickly, but then the actual experience of using it isn't great. And it's interesting when you start looking at the products you use every day from this lens, because you start to realize just how much we've neglected this other side of the performance coin. All right, that's my talk. Don't forget cats. Follow me on Twitter. Thank you.